In this lesson, we're going to start to make some connections between the unit circle and what we're going to be doing in graphing in the second half of the unit. So in my directions, it says complete the following diagram to the right to see how the unit circle can be used to find each of the 6 trigonometric functions. So we have steps. First, we're going to draw the unit circle, which I'm going to do my best. It's not a great circle, but not bad for the video. I'm just going to label a point out here, 1, 0, because if it's the unit circle, we know the radius is 1, and that kind of shows that. On the axes, draw an angle with its terminal side in any quadrant. So I'm going to keep it in the first quadrant, but we know no matter what quadrant we're in, we would still draw a reference triangle from our previous lesson. So now it says draw a triangle using this angle similar to the previous lessons. So that means I'm going to take the point that intersects the unit circle and draw a line straight down to the x-axis. We're going to label the point where the unit angle intersects the unit circle, and that should just say angle, not unit angle there. So that's xy. Now we're going to label the sides of the triangle using x, y, and 1. So here, we know the 1 has to go on the radius of the circle. So that goes here. It's also the hypotenuse of the triangle. We know the x, based on the x-axis, goes down here. And we know the y, based on the y-axis, goes on the side. So this is always our picture for the unit circle. So from here, if you want to pause the video, we're working from the angle, so I'm just going to label that, that's theta. See if from this triangle, you can find each of your 6 trigonometric functions using the ratios. Okay, so hopefully you've done that on your own. So I'm going to look at my picture. Sine of theta is opposite over hypotenuse, so that's y over 1, which is really just y. Remember, that's an important concept on the unit circle. Cosine is x over 1, so that's just x. Tangent, opposite over adjacent, is y over x. And then we're just going to flip for our reciprocals. So cosecant is the reciprocal of sine, so that gives me 1 over y. Secant is the reciprocal of cosine, so 1 over x. And cotangent is the reciprocal of tangent, so x over y. So the idea is, once we have the unit circle, we can express all 6 trig functions as some representation with an x or a y or both. And as I said, that's going to be important when we move to graphing. So we're going to see 2 ways that this plays out. We're going to do the old way of doing the problem. So here it says an angle in standard position intersects the unit circle at the point radical 5 over 3, negative 2 over 3. So I'm just going to draw that picture. Here's the unit circle, labeling that point out here to show that it is the unit circle. And the angle intersects at this point that's positive, negative, so I'm in the 4th quadrant. So it doesn't really matter where I put that point, but I'm going to draw my angle. Remembering your angle really goes around this way. But to answer all questions, we draw a reference triangle. So here's my little triangle I'm going to use. This is my angle. This is really theta out here, but we're using this angle here as a reference angle to solve the problem. So here we want to find cosine of theta and cosecant of theta. Labeling my sides. Radical 5 over 3 is the x, so it's going to go on this side. So radical 5 over 3. Negative 2 over 3 is the y, so that goes on this side. And then lastly, we don't even need to use the Pythagorean theorem here because this is the unit circle. The hypotenuse or the radius of the circle is 1. So I know these are kind of hard to see. I'm just going to circle my sides. So now I'm going to use this information in my picture to start to find cosine and cosecant of theta. So for cosine of theta, I want to take the adjacent over hypotenuse, so that's radical 5 over 3 over 1, which is radical 5 over 3. And for cosecant of theta, I need to do the reciprocal of sine, so I'm going to do hypotenuse over opposite. So 1 over negative 2/3. We're going to keep change flip. I'm going to make the numerator 1 over 1, and I'm going to flip the bottom fraction. 1 over 1 times negative 3 over 2. So I just get negative 3 over 2. So here are my answers. Now on this side, we're going to show that even though the picture is really nice and you should really always draw one, we could just figure out these answers using the identities above. So I'm going to scroll up on the page so I can see them, hopefully. So in this problem, when I want to find cosine of theta, remember we had radical 5 over 3. I can't see it anymore, but that's what we got when we used the picture. Cosine of theta equals the x value on the unit circle, and the x value on the unit circle is radical 5 over 3. So that's a really quick way, if you know your identities, which is what we have up here. Okay, those are those relationships. We can find it quickly. Cosecant of theta on the unit circle is 1 over y. So 1 over negative 2/3. We already did this. We know that that keep change flips to negative 3/2. So the idea is the picture supports what we now know from our identities. So turning over to the next page, we're going to see another interesting relationship that comes up with the unit circle. It says the unit circle gives us a helpful identity involving sine and cosine. Now, we're just going to kind of introduce this in this course. You would use it more in pre-calc, and there's a lot of other identities that come from it, just an introduction here. So we're going to start out the same way. We're going to draw the unit circle on the axes to the right. We'll show it's the unit circle with the 1, 0. And we're going to do the same things. This time I'm going to draw my angle in a different quadrant. So it says draw an angle with its terminal side in any quadrant. Maybe we'll go quadrant 2 this time. So here's my angle, but we're really going to draw, for this part about the triangle, a reference triangle. And this, while this is theta, we're really using this angle in here to find those values. So label the sides of the triangle. This is x, this is y, and this is 1. If we were in class, I would talk about how, this is really negative x, but we're not writing that. The value of x is negative, but we're still just using the x value there. Okay. So just like before, when we do sine of this angle is opposite over hypotenuse, so y over 1, which is y. Cosine is x over 1, which is x. And this is our big concept that we're going to use moving forward. Any point on the unit circle is cosine theta sine theta, because cosine is always x and sine is always y. So the next step in this identity is to write the equation of the unit circle. So you'll remember that the equation, because the center is 0, 0, we just have x squared plus y squared, nothing subtracted for the center. And then r squared is on the other side, radius squared, 1 squared is 1. So to get this Pythagorean identity that we're working on, what we're going to do is substitute cosine theta for x and substitute sine theta for y. So we're going to substitute the appropriate trigonometric functions for x and y in the equation of the unit circle. So this is going to give me cosine squared theta plus sine squared theta equals 1. Now you'll notice you do write the squareds kind of in a weird spot. So I'm substituting cosine theta for x, but when we write that, it's just kind of a notation thing. You just write the squared in between the function and the angle sign. Okay, so this gives us, this equation is known as the Pythagorean identity. It is called an identity because it is true for any value of the angle. So I'm going to write it here. Typically it's written with sine first. So the Pythagorean identity is the sine of the angle squared plus the cosine of the angle squared equals 1. and that will always be true. So we're going to look at a couple examples that will show how this works, or just different examples of showing it's true. So down on the next part of the page, you'll note here it says you need to know how to derive this formula. So you need to know how to draw the unit circle and kind of go through those steps to show that it's true. So here, based on that, if we take the sine squared of an angle plus the cosine squared of an angle, it always equals 1. So this angle, this theta, would stay the same. So it is true that the sine squared of 45 plus cosine squared of 45 equals 1. The same is true if this is 100 here and we're using sine squared and cosine squared and adding, this should be 100 degrees. And lastly, the sine squared of pi plus cosine squared of pi also equals 1. So just to kind of show this is true with a couple examples we know, for example, I know the sine of this would be the sine of 45 degrees because that's what pi over 4 is. So radical 2 over 2 squared. Cosine of 45 is also radical 2 over 2. If I square both of these, and I'll erase this in a second, this is more just something you can watch, and I square, this is going to be radical 2 squared is 2. 2 squared is 4. So I end up with 2/4. Same thing with the next fraction. 2/4 plus 2/4 equals 1. Looks good, right? 2/4 plus 2/4 does equal 1. Another quick example over here. The sine, if we think about the unit circle and we're over at pi, this point over here is -1, 0. So on the unit circle, I know that the sine value is the y of the point. So if I take the sine of pi, that's 0, so 0 squared, the cosine of pi is the x value, right? Cosine is x. -1 squared equals 1. Looks good, right? 0 is 0, 0 squared is 0, -1 squared is 1, and 1 does equal 1. Okay, so that's the Pythagorean identity. I could pick a weird angle like 2.5 degrees. It will still work for any particular angle.